Okay, number 2. Remember that we have all the information like we did for the first one. We have all the information at the top, which we've already highlighted. We also have the resources in our notebook that are the family of quadrilaterals. We can use properties off of this, and we can also use definitions to see if anything can help us prove what they want us to prove or answer questions they are asking. Okay, so number 2, it says 3 of the vertices of rectangle LMNOR. L is 2, 3, M is blah, 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 blah. How do you prove something is a rectangle? So let's talk about how we prove something is a rectangle. So let's go ahead and look at what we know about rectangles. So a couple things we know about rectangles. The first thing is, look at the little tree, it's coming out of the parallelogram, so it is a parallelogram, which means opposite sides are parallel. Other thing we know is that the opposite sides are congruent. Now, no one says all 4 have to be the same, although they could, but this side and this side have to be congruent to each other, and also the top and the bottom have to be congruent to each other. And the other thing that's special is that it has 4 right angles. And let's check out our definition. It says a quadrilateral with 4 right angles. So, as long as we have 4 right angles and opposite sides congruent, and we also know they're going to be parallel because it's a parallelogram. So we know a lot of stuff about this rectangle. So let's go ahead and list some stuff about rectangles. So it says, how do you prove something is a rectangle? So one of the things it has to have is opposite sides congruent. Another thing it had to have is opposite sides parallel, because it is a parallelogram. And the third thing that was special is it has to have 4 right angles. So that's the stuff it has to have. So let's go ahead and look at our little cheat sheet at the top. In order to prove opposite sides congruent, check for congruent sides by finding lengths and distances using the Pythagorean theorem. So we're going to have to find lengths using the Pythagorean theorem. I'm going to put P, Y, T, H. Okay, opposite sides parallel. How do we prove parallel? By same slopes. Okay, so we're going to have to count rise over run. So we're going to look for same slopes. And the last one, 4 right angles. We need to have opposite reciprocal slopes. So we need opposite reciprocal slopes for the 2 that join on the corners, right? So we need opposite reciprocal slopes. Okay, so that's the stuff we need. Opposite reciprocal slopes. Okay, so let's go ahead and graph this. 3 of the vertices, so we have L is at 2, 3. Remember, stop your video, graph it, and then turn it back on. 2, 3 is L. M is 1, 0. So that's the right one and up 0. That is M. N is 7, 2. So over 1, 2, 3, 4, 5, 6, 7. And down to -2. Okay, so that's over here. That is 7. I hope this graph is big enough. We'll figure it out. N. Okay, so it looks like L, M, N, O. So the order goes L to M to N. So where does our O have to be? It's got to be up here somewhere, right? So we need to figure out exactly where it's going to be. So let's take a look at this. So we do know we need opposite sides being the same length. Doesn't look like, I'm going to go ahead and connect some of these sides. From here to here we have, and from here to here we have. And we think the other one's got to be out here. So let's try to do opposite reciprocal slopes. Same slopes. Okay. So because we can actually find this length. I don't know. What do you want to do first? I think I'm going to do opposite reciprocal slopes because I feel like that's easier than Pythagorean theorem. Okay, opposite reciprocal slopes. So if I want to find the slope of this side right here, so this is going to be my yellow side. Let's find the slope of that side. That means I need to do rise over run. So that's rise, 1, 2, 3, and run, 1. So the slope of this side is going to be rise, 3, and run, 1. And that is going uphill, so having a positive slope makes sense. Rise 3. Now this side over here that's missing, what has to be the slope of it? If the slope of this side is rise 3, 1, run, then that means the slope of this side also has to be rise 3, 1, run 1, because it says opposite sides are parallel, so they have the same slopes. So from here I have to rise 3 and run 1. Boom. So that's going to put me right here. So it looks like that is where my point O is going to be. So possibly we're looking at, that's 8, 1. So we are looking at 8, 1. We're going to check other stuff first. We think it's at 8, 1. Okay. So let's go ahead and draw that there. That's where we think that side is, with the same slope of 3 over 1. Now let's check the other opposite sides, because these two are the those two match. So that means this piece and this piece would have to match also, right? Sorry about my sloppy line there. Okay, so let's check the slope of this bottom one. So it is going downhill. So what's going to be true about the slope? The slope is going to be negative, right? So I can go from either point. Remember, I could start at M or N, whatever I like. Let's mix it up. Let's go from M. So that means I'm going to go down 1, 2. Oopsie, that's a 3. Duh. Down 2 and over. Let me make that, clean that up. So down negative 2 and over 1, 2, 3, 4, 5, 6. So the slope of that one is negative 2 over 6. Now we could simplify that to negative 1/3. Or we can leave it negative 2 over 6 for right now, because we got to look at the top. And that means the slope of this light blue has to also be that, which is a little bit crooked because it's actually over here. It's kind of hard to write on a screen. Okay, so well, let's see if this one is down 2 and over 6. So let's look. So to get from this point to this point is down 1, 2, over 1, 2, 3, 4, 5, 6. So it does look like the slope of this side is negative 2 over 6. So it looks like our point of 8, 1 is working out so far. Let's go ahead and check some side lengths, because we, the other part, we need right angles, right? So if we have a slope of 3 over 1, and then we have this other slope of negative 2 over 6, which simplifies to negative 1 over 3, are these opposite reciprocals? Op. Recip. Let's ask ourselves, what's opposite reciprocal? Means what? Upside down and change the sign. So we're looking at changing the sign and flipping it upside down. So let's see if we did we flip it upside down? Sure did. Did we change the sign? Positive, negative, sure did. So these are opposite reciprocals. So that means we do have right angles in our picture. And since they match, so we have parallel lines because the slopes are the same on the top and the bottom. My picture's about a hot mess now. So this is parallel to this because same slope. That is parallel to that because same slope. And we also have 4 right angles. Now the other thing it has is opposite sides congruent. So let's go ahead and check some lengths. So let's go ahead and look at some lengths. So let's find the length of, I need some new colors here. What color did I not use? Purple. Let's find the length of this. And remember, to find the length, we got to do Pythagorean theorem because we can't count boxes. They're diagonal. So how much do we rise? 1, 2, 3, and run 1. So this side is 3, and this side is 1 for our fake right triangle. So that is a 3 squared plus a 1 squared equals c squared. Okay, so that's a 3 times 3 is 9 plus 1 times 1 is 1 equals c squared. Combine like terms here, we get 10 equals c squared. And then we need to take the square root of both sides. In my calculator, remember you're going to hit the second, second button, and then the x squared button, and then your radical pops up with the parentheses, and you put the 10 in there, and you get approximately 3.16. So C is approximately 3.16. So that's the length of this little purple side here. Now let's see if the other side is going to be the same. So let's take a look at it. If we go from this bottom corner, that's 1, 2, 3, and then over 1. So 3 and 1, that's the exact same problem, 3 and 1, and I get 3.6. So both of those opposite sides are congruent to each other. Now let's check these light blue sides right here. So the same thing here, we have, we're going down 2 and over 6. But when we talk about a right triangle and lengths, we don't use negatives, right? We're using that for slope. So this is my fake right triangle. So that means that this side is not a -2, it's just a +2 because it's 2 units long and 6. So to find the length of this orange side right here, I'm going to use my right triangle of 2 and 6. So let's go ahead down here. That's a 2 squared plus a 6 squared is equal to a c squared. So 2 squared is 4 plus 6 squared. 6 times 6 is 36 equals c squared. Add these two together, and 36 plus 4 is 40 equals c squared. And then I got to take the square root of both sides. And I get, oopsie, I don't know what that is. Second x squared, put 40 in there, and I get approximately 6.32. Approximately 6.32. So the length of this side is about 6.32. Look at that. Doesn't you see the boxes we can count? There's like 1, 2, 3, 4, 5. It looks like it's about 6.32 long. So that number does make sense. Always see if your answer makes sense. Let's do the top here. You see this other light blue side of my rectangle? What is it going to be? Now we said we have the fake little triangle right here. You see it right here. Boink. So that is down 2 and over 6, like we said. But remember, it's a length now, so it's just 2. We're not going to worry about the negatives because we're not doing slopes. So this is 2 and 6. Now, 2 and 6, we just did 2 and 6, right? And we get the exact same thing. So that means that this top piece is also approximately 6.3. What was it? 2? Can't even remember. Oh yeah, it's right there. 2. Okay. So let's go back to our questions and see if we answered everything. It says, what are the coordinates of the vertex? And this is a beautiful answer. 8, 1 worked out for us. What are the slopes of the sides? So we have the slopes of this side was 3 over 1. That side was also 3 over 1. And then the slopes of the top and the bottom were -2/6. which we simplified to negative 1/3. So we do have those answers. You can write them on your paper. And then what are the lengths? Two of the sides we came up with had a length of 3.16. That would be this side and this side, the short sides. And then we had the other two lengths at 6.32 approximately. So you are going to do the rest of this paper. Don't just do these two videos. Try to do the exact same thing the way we did these.